Welcome to part one of our discussion of the Java function functional interface. In this part of the lesson, we'll describe the structure and functionality of the Java function functional interface and see how it can be used in conjunction with Java lambda expressions and method references. As always, we'll show this in the context of an example you can find in open source forum from my GitHub repository, available at the link below. This particular example will showcase the use of the function functional interface in conjunction with the Java Collection Framework's concurrent hash map class. So what is a function? A function is essentially a way to apply a computation on one parameter and return a result. As you can see here, the Java function functional interface takes two type parameters, t and r. T is what's actually passed as the parameter to the apply abstract method, and r is the return value that comes back from the apply abstract method. We're going to demonstrate the use of the function functional interface in the context of an example you can find in the EX9 folder in my GitHub repository. This particular example will define a map that caches the results of prime number computations. As you can see here, this map, which we call prime cache, is a concurrent hash map that maps integer to integer. The first integer, which is the key, will be the prime candidate, the number we're trying to determine if it's prime or not. And the second value is going to be the result of applying the prime number computation, which will either be 0 if it's a prime number, or it'll be greater than 0 and be the smallest factor if it's not a prime number. We're going to use a very cool method here that comes from concurrent hash map called computeIfAbsent. And the way this method works is if you pass in a key, which in this case would be the prime candidate, if we've already pre-computed the value in an earlier call, we'll just return that as the result from computeIfAbsent. However, if the value hasn't been computed yet, then we're going to call a prime checker method. So if the key isn't associated with the value, then we're going to atomically compute the value using the given mapping function and then enter the value into the map. So as you can see here, we're going to be passing in one of two things. And this particular method that's called computeIfAbsent will act as a so-called atomic check then act computation. And you can see that that's described in the link at the bottom of the slide. So we have a couple of different ways to do this. One way is to pass a lambda expression that calls a function. As you can see here, you would pass in this lambda expression that would take a key, and it would go ahead and return 0 if the number is prime, or the smallest factor if it's not prime. And that's the prime checker method you see at the bottom of the slide. Alternatively, you could pass in a method reference instead of passing in a lambda expression. I prefer the method reference whenever possible, so that's the one we're going to talk about here. Let's now go ahead and take a look at the implementation of computeIfAbsent that you would find if you look at the source code for the concurrent hash map class. As you can see here, computeIfAbsent is passed several parameters, one of which is a mapping function. We'll talk more about that in a moment. That, of course, is a function using the function functional interface. And at the appropriate part in the implementation of computeIfAbsent, if we don't find a value that's associated with the key, then the mapping function's apply method is called in order to compute the value that's associated with the key, and that then gets added to the map. Now, there's a little bit more syntax we have to briefly cover just to make sense of the example for completeness. So as you can see here, as with predicate, we have the question mark super K type shown here. In this context, as we discussed before, super is a lower bounded wildcard that restricts the unknown type to be a specific type or a super type of that type. Likewise, this expression, this type expression, question mark extends v, which is for the value, of course, has extends being a keyword that's a so-called upper bounded wildcard. And that restricts the unknown type to either be a specific type or a subtype of that type. Super and extends play somewhat different roles in Java generics. So take a look at this Wikipedia link at the bottom of the slide if you want more information about super and extends. But for right now, let's keep moving ahead. As you can see here, what happens is the prime checker method reference that's going to be used when we call computeIfAbsent will be bound to the mapping function parameter. And then at the appropriate time, if it's necessary, if there's not already a value associated with that key, the mapping function's apply method will be called. And as you can see here, it's as if it was expanded to say, if val equal prime checker of parameter key, if that doesn't equal null, that means we computed a value, and we're going to go ahead and store that value in the concurrent hash map as the new association with that key. So that's the end of part one of our discussion of Java's functional interface.